Welcome everyone to the Cloud Keynote track, Building Scalable and Agile Infrastructure for the Cloud Era. My name is Sally Bayment and I'm Vice President of Marketing at Juniper. And joining me today is Ashok Ganison, Vice President of Product Management. And we're here to talk about some of the key technology building blocks and key innovations that are needed to build an application-driven infrastructure, one that delivers the absolute best application experience, particularly with today's heightened and increased user expectations. But before we start, I'd just like to spend a little bit of time putting all of this into perspective, particularly as it relates to some of the key market trends and the key catalysts that are driving the modern application economy. And all of these are in overdrive right now based with our current situation. And let me start with digital transformation. The relationship between businesses and their customers is increasingly being defined by digital. Everything is getting digitized, and everyone is talking about digital transformation. In fact, the collective sum of the world's data is expected to expand pretty dramatically over the next few years, driven by the development of digital transformation. But to put things really into perspective, particularly in today's environment, in the recent earnings call, Microsoft CEO mentioned that they witnessed 2 years worth of digital transformation accelerated in just the past 2 months as a result of remote learning, more remote collaboration and teamwork, to customer service and sales, to just that critical cloud infrastructure, which moves us to connectedness. Network traffic continues to explode with absolutely no end in sight. And much of that is driven by broadband penetration and also increased speeds. Video traffic certainly is driving the bulk of that traffic growth, particularly in terms of bandwidth, but also just the sheer number of connected things, the sheer number of connected devices, which according to Gartner is expected to grow to over 25 billion next year, up from about 14 billion last year. Everyone wants access to their stuff anytime and from anywhere. And we all want the same seamless and ubiquitous experience, whether we're connected over a mobile connection or over a fixed wireline connection. And it's that access to anything at any time that is driving this move to cloud, multi-cloud, and all cloud. Workloads, content, and data are now spread across private clouds, public clouds, and even edge clouds. And in fact, the number of SaaS applications that on average that a typical large business runs today, just to run their business, is over 200, 203. And that brings us to security and security vulnerabilities. Security is needed everywhere, particularly as the attack surface expands, and so do the number of vulnerabilities, security vulnerabilities. And with everyone and most people now working remotely, the attack surface literally expanded overnight, creating opportunities for hackers and obviously increasing the vulnerabilities for both businesses and users. Security is absolutely top of the enterprise IT agenda. These trends are global and they absolutely know no boundaries. The cloud application experience is incorporated into every facet of our lives today. And so it is with that backdrop and that background that I'd like to reintroduce Ashok and just ask Ashok to talk a little bit about the technology underpinnings that are needed to build an application-driven infrastructure, again, one that delivers the best application experience. Ashok?
Thanks, Sally. That's an awesome introduction. The key market drivers and technology trends for an app economy are certainly in overdrive, as you rightly stated. Now, app economy depends on an infrastructure that helps applications in many areas, whether it's scale of an application, whether it's performance of an application, resiliency, how do you support it, how do you upgrade it. End of the day, it all translates to better user experience. Rami had mentioned in one of his previous sessions that infrastructure and networking need to be completely self-driven and should get out of the way and be transparent to applications. That is extremely true. We need to make sure that the infrastructure is simple and it is out of the way of the application. Now, there are multiple inflection points happening, and it will be easier if I group them into building blocks. So specifically what I want to do is I want to group them into 3 building blocks. The first one is cloud networking. The second one is AppFabric, and the third one is AI ops. So let me group this, and then we'll get into details on each one of them.
Ashok, thank you. And before we actually click down on those 3 key building blocks that you mentioned, maybe tell us a little bit first about the application-driven infrastructure.
So certainly, Sally. So in order to do that, let's wear an application developer and administrator lens, and let's see the world from their point of view. The modern applications are being implemented as microservices. That is, it's a set of services that collaborate to deliver the end user experience. Now, these services communicate with each other using well-published APIs, which we call as application programming interfaces. Now, what this allows is it allows extensibility. So a new feature can be added by bringing a new microservice, or an existing feature can be enhanced by just enhancing a single microservice or few microservices. It also allows for ease of upgrade. This modularity in application allows for ease of upgrade, fixing problems, because a given microservice or a set of microservices can be upgraded independent of another one. The key requirement is the infrastructure should be flexible and the API should be backward compatible. Now, there are still a lot of problems to be solved in order to make this work seamlessly. The first is we need the ability to discover these services. We have to figure out where these services are running, whether it's running on-prem or off-prem. And we also need to allow secure and efficient communication between these services. We should monitor how these services are behaving, how the interlink between these services are behaving, and improve the overall availability, scale, and performance of these microservices, which basically results in better end user experience. Now, this is not a new concept. This software development principle, it's been around for decades, right? It's just that it's becoming easier now. A lot of improvements happening in the server architectures with multi-core CPUs, like the networking is growing in speeds and feeds. And also with cloud, it's easy to allocate resources. Whether it is private or public cloud, we can easily allocate resources to a workload. Now, these applications are also being written to take advantage of cloud, whether it's public cloud, multi-cloud, private cloud, right? So we call it cloud first or cloud native. But the key thing is there is a whole set of infrastructure improvements happening, specifically around container technologies, Kubernetes, service mesh, etc. The ability to basically orchestrate these microservices in any environment, ability to securely connect them across these different environments, ability to insert application services like firewall, load balancer, ability to secure them, ability to provide storage, whether it's ephemeral or persistent, encryption, right? So there is like significant innovation happening in the space, and the goal is to simplify the overall operation of how an application will get deployed, managed, upgraded, etc. Last but not least, there are also significant disruption happening in the compute space. So a couple of decades back, we invented this thing called control plane data plane separation in the networking industry. The idea is x86 was not good in networking functions, so we actually created something called NPU, Networking Processing Unit, and we moved the data plane to the NPUs, and we kept the control plane in the x86. The same thing we feel is happening in the compute space. So the kind of workloads that are being run, x86 is not optimal for them. So we are seeing new specialized processors coming into the server space. The first one that came was GPU, which was much better than x86 in doing big data analytics, graphical processing, etc. And now we are seeing a new wave of processor coming called DPU, Data Processing Unit, which is much better in handling data. And it sits on the PCIe bus. It offloads the data processing from GPUs, storage, and CPUs. So the key thing is these server re-architecture, they are happening without application being aware of it. So if an application is written properly, they'll just run better in a modern server that has DPUs and GPUs. No changes are needed to the application. So we are in the beginning of a whole new chapter of infrastructure upheaval, the one that I would like to call app-driven infrastructure. And I think it's a great time for all of us with the amount of innovation and changes happening in this space.
So thank you, Ashok. So what I'd like to do is just explore those three technology building blocks in just a little bit more detail. And maybe if we can start with cloud networking. So networking obviously has been around for a long time. And we at Juniper probably know networking better than anyone. What is needed and what's different about an application-driven infrastructure?
Yeah, so networking has gone through many changes over the years. And we've seen a lot of innovations in the networking space over the last 2 to 3 decades. Like we started off with control plane, data plane separation. We basically created this new processing unit called NPUs, or network processing unit. Then we went into open networking, software-defined networking, convergence of various traffic types over IP MPLS. So it's gone through a lot of innovation. Like what's different now is the speed at which innovation is happening in the networking space, particularly in the data center space. So in data center, it's all driven by applications and servers. The server connectivity is increasing and it's moving from 1 gig to 10 gig to 25 gig, and now can do multi 100 gig and 200 gig connectivity into the network. The network has to keep pace with that. And we are driving new technological innovations in many areas, whether it's SerDes, whether it's ASIC technologies, memory technology, optics. So to give you an example, right? So you can buy a system on chip, like which we call as pizza boxes today, that can support 12.8 terabits in performance. That is 32 ports of 400 gig or 128 ports of 100 gig in a single like 1RU type box. Now, we expect the speed to double next year to 25.6 terabit. And like we expect that to double again the year or the year after that. And what this allows us to do is it allows us to give an infrastructure that can scale for the applications and the server. So you can easily connect 100 gig, 200 gig connectivity to the server with 400 gig uplinks today and 800 gig uplinks in the future as the SerDes kind of move from like 50 gig to 100 gig. So it's not just the ASIC technology that's happening in the SOC space, it's also happening in the deep buffer space. So if you look at the deep buffer boxes, like we used to build boxes that had 36 ports of 100 gig in the industry, and now it is 36 ports of 400 gig. So that is 14.4 terabit in a single 1RU line card. So we have quadrupled the performance even for deep buffer systems just over a few years. And we do expect this to continue. So it's not just about speeds and feeds and performance. As you pointed out, the security architecture must evolve too. And the applications are everywhere, and we need to evolve the security technology. And we need to see what role the networking can play when it comes to security. So there are many innovations we are bringing to this space as well. So first, you cannot predict what you don't see. So like we put 8 million counters in our current generation ASIC called the Triton that is being built for, that's being used to build the PTX product line. Now, we are also increasing the scale of access control list. We're also bringing capabilities like MaxX so that we can provide secure connectivity between data centers or anywhere you need them, right? So we've also partnered with key players. To give you one example, we partnered with Corero so we can actually provide state-of-the-art DDoS, like denial of service protection for our customers. Now, we'll continue to innovate in this space. And as we bring newer ASICs to market, like telemetry and access control list and how we integrate with application services is going to be very key. There are also innovation happening in the optics space. So by the end of this year, we do expect that there'll be ZR and ZR plus optics that will completely transform how data centers are interconnected, how these metro architectures evolve. There is also a lot of research and development happening in this technology called silicon photonics and co-packaged solution. The goal again is basically to provide more bandwidth, simplify, reduce cost, reduce power requirements in these products. Now, the key message I want to drive is Juniper is in the front and center of all these technological innovations. Like we are engaging our customers very early to make sure that we jointly transform the infrastructure.
Ashok, thank you. It really, really interesting to hear about these individual innovations. But one question I have is, how do these all come together to help deliver this application-driven infrastructure?
So that's a great question, Sally. So we've talked about 3 eras of networking in the past, right? We talk about scale up, scale out, and multi-cloud. So the reality is there is no one right answer. It completely depends on what a customer needs. Right. So while we encourage our customers to build a scale out architecture, like scale up may be the right thing for some customers and some customer needs, right? So that's why we have a broad portfolio of products, whether it's a deep buffer spine product or a lean buffer spine product or a deep buffer leaf product, lean buffer leaf product. So based on a customer need and an application need, we can basically create the right network architecture for them. The other key consideration is power, cooling, cost per bit. So again, the rich portfolio that we have, we can optimize the networking for our customers. Now, we've not stopped at underlay networking. We have invested in technologies to take networking to the host. So with our Contrail products, we have basically brought networking to the host. And we're also leveraging acceleration wherever we can. So for example, we have integrated with SmartNICs with Contrail so that we can bring some acceleration to the networking performance for applications. Now, what we've done is basically we've created Contrail in such a way that we can allow our customers to take any workload, whether it's bare metal server, whether it's virtual machine, whether it's container. They can take them anywhere, whether they want to keep it in on-prem DC or whether they want to go to public cloud, edge cloud, they can take them anywhere. And the key is they can do that with complete security. Now, where possible, we've also accelerated these services so that they can get the best out of these application services, whether it's through leveraging SmartNICs or other ways. We have basically provided acceleration to these services that we offer to these applications. Now, security is always a challenge when it comes to scale out and distributed architecture. So what we've done is we've modernized our whole security infrastructure and offering, right? So we do have Contrail security. We have integrated Contrail security with containerized SRX, with virtualized SRX, and also physical SRX, right? So you have the ability to run these services anywhere and put them in the right place, whether it is protecting from north-south traffic or whether it's protecting the east-west traffic, right? We're also evolving how we interact with our customers. So while we do have point products, we are not stopping there. We're giving them completely integrated, well-developed solutions, and we're giving them reference architectures. We are making it easy for them to consume. And of course, if a customer needs help, they can certainly leverage our professional services as well as our system integration partners. So we have enabled our professional services team as well as our system infrastructure team to basically simplify how our customers can consume our products as well as solutions.
So Ashok, these innovations and advancements in the underlying speed and connectivity and performance, they all need to come together, particularly as we move up to that service level abstraction that you talked about earlier. How is that service abstraction possible? And what are the key advancements that are really happening to improve the application fabric performance?
Yeah, so if you look at applications, they depend on three key infrastructure elements, right? They depend on compute and storage, they depend on networking, and they depend on some application services. And there are significant disruptions happening in all those three areas. We already touched on compute, like how we have a new wave of processors like DPUs and GPUs taking workload off of CPUs to basically give you better performance and better scale from a server standpoint. There are also significant enhancements and advancements happening in the storage space. Again, we moved storage to fiber channel, the block storage, then we did fiber channel over Ethernet, but it didn't stop there, right? So we have been continuing to evolve storage networking, and there are new technologies coming out like NVMe over Fabric. And the idea is basically, how do you handle congestion management? How do you make sure that there is data integrity? How do we make sure that the data is protected, right? So there's a lot of innovations happening in that space. Now, there is also changes happening and innovation happening in what we call as composable infrastructure. The idea is I should be able to disintegrate the server into separate components and recompose them, so that the idea is I can get like scalable CPU, scalable memory, and scalable storage, like by composing them on demand by application, right? In all this, the networking is pretty key, and we need to start thinking about low latency. We need to start worrying about jitters. We need to start thinking about congestion management and how do we handle congestion at various points in the network. And we also need to start thinking about encryption, because things that were sitting inside the server in a private bus is now going over IP. So we need to think about encryption. Now, In the area of networking, we did talk about the separation of physical networking from application networking, the decoupling that happened over the years. And we talked about Contrail, which basically provided the virtualized networking or application networking. Now, what that allowed our customers to do is they can build an infrastructure where the applications can move around freely. They can move around freely with security. And we've also brought efficiency wherever possible, right? Now, this overlay networking or network virtualization can be implemented in top of rack, or it can be implemented in server, in the NIC, or in the CPU, or it can be implemented in cloud, right? Again, we know that our customers want the flexibility to use them wherever they want it, right? And there are also significant changes happening in the application services, right? It's not stopping at just the networking. It's also happening at the application services like firewall, load balancer, app security, message encryption. So there is changes happening in that space as well. So the traditional architecture was we put a firewall load balancer at the entrance to the data center because most traffic enter in, and then we basically make sure it's a good traffic, and then we load balance it to various servers sitting behind it, right? But that architecture will require some rethinking because it's not just the north-south traffic. We also need to think about east-west traffic as we get into this microservices architecture, right? So again, the firewall, the load balancers, they're all going through evolution, and significant changes are happening, right? And what we want to do is basically give that capability to our customers at an infrastructure level so that they don't have to worry about how their applications are placed and where they are placed. There is a need for telemetry at all layers of this infrastructure. And this should basically be rich enough so that the monitoring application can pull them and piece them together and provide like a good map of what's happening in the infrastructure and how is that impacting application experience, right? So that's extremely key. And I want to highlight that at all layers, the telemetry becomes a very key component. And we certainly have a lot of things to offer in that space.
So that's great, Ashok. Thank you. So how do these all work together, again, to improve the application fabric performance?
Yeah, this is where I think the concept of AppFabric becomes very important. The idea behind the AppFabric is it provides the ability to allow the application to move freely, to have secure communication between the subcomponents or with the end user and rest of the world. The ability to store data, whether it's on-prem or off-prem, right? And ability to scale and perform to meet the end user goals. Now, the industry is driving this concept called service mesh. So the service mesh, the idea is you have these microservices. How do we basically stitch them together in a map, and how do we provide like services between them, right? And there are significant developments happening in the space, and Istio is a good example where key players like IBM, Google, and Lyft have come together to develop that control plane stack. Now, I think that the control plane like service mesh has a very key role to play, and they can play the role of what BGP played in the creation of internet, right, and the scaling of internet. Now, we are fully supportive of this. We are looking at ways to tie these pieces together into one unified architecture so that we can create this thing called AppFabric that will allow our customers to take their application and run them anywhere, whether it's on-prem, off-prem, cloud, public cloud, edge cloud. So that's what we are working towards.
All right, so in these highly dynamic cloud environments, operationalizing all of this, operationalizing the workloads and this agile infrastructure, all seems pretty complex and challenging. How is that done, and what is needed to operate, not just at scale, but at hyperscale?
Yeah, so we talked about the need for telemetry sensors at all layers, right? And the ability to pull them together. And that's what I would like to call as AI ops, right? So in a dynamic environment where applications are modern, your operations cannot be static and it cannot be reactive, right? You need to get into descriptive, predictive, prescriptive operations, which we call as AI ops. Now, how many times have we run into a situation where we did not have the data to understand what happened? If an application is slowing down, how do we find out what is the cause for it, right? Or if an application is unavailable momentarily, how do you find that? And most of the time, we don't have the right data at the right time, and we're always challenged, right? And we cannot take any actionable insight if we just don't know what happened, right? So the goal is basically to provide a solution where we can collect all the important data in one place, right? And we can actually connect the dots and monitor how things are functioning, right? And once we have that, then we can do the analysis and we can build this knowledge graph, right, as to what is happening. And of course, you can extend that to now control things in an artificial intelligence manner, right? So to improve the behavior of the infrastructure. And this is what we call a self-driving network or closed loop infrastructure or closed loop automation. Now, what we have done is basically we have embraced the microservice architecture, right? Whether it is collecting the telemetry data, whether it's doing analysis, whether it's doing actions. So to give you a few examples, right? So we have Contrail Insight, and it's a microservice that gives you a lot of insight into what's happening in the overlay networking or application networking. We have HealthBot, which basically gives you similar insight when it gets into Junos and Junos devices, right? And we can connect these two and to show basically like what happens between the underlay and the overlay. If an application is not performing, is it a server problem? Is it a storage problem? Or is it a network problem? We can actually zoom and show where the problems are. Now, we have done similar things for our core networking with products like Northstar, and for security through our products like Security Director and ATP products, right? So the goal is basically to pull the relevant information, take knowledge out of it, and take actionable insight, and basically we can automate that whole thing. And that's what I would like to call as AI ops, right? Now, these also need to fit into the larger analytics system, and we have open buses support like Kafka bus where needed so that it can integrate into a larger subsystem and customers can actually get a seamless closed loop information for the entire infrastructure, right? So that's basically what we are working on, and that's what I would like to call AI ops.
So thank you, Ashok. And as we bring this to a close, if you could just recap those key technology bets that Juniper is making that quite frankly have the potential to transform cloud infrastructure.
Yeah, absolutely. To summarize, like we are grouping all our innovations into 3 building blocks. The first one is cloud networking, where we are bringing a lot of innovations like 400 gig, your new optics, your pervasive security, your telemetry sensors, like, and simplifying our customer deployment, whether they choose to go with scale up, scale out, or multi-cloud. The second key building block is AppFabric or App Infra. So the goal is basically to modernize the infrastructure to serve the applications better, where we are bringing modern innovations on storage technology, modern innovations on application-oriented networking, also known as the overlay networking, and evolution of application services like firewall, load balancer, encryption, deep packet inspection, and all those kind of services. The third key building block, a very important one, is AI ops, where we are bringing all intelligence in one place so that we can monitor, analyze, and take some action, whether it's manual action or whether it's automated action using AI-driven technologies, right? So we also fully understand that every customer is unique and we do want to integrate with their systems. And certainly we have our professional services and system integration partners to help with that.
Thank you, Ashok, and thank you everyone for joining today's session. I would like to encourage all of you to explore some of the other sessions at the virtual summit today, particularly if you would like some additional information. Thank you again.
Thank you.